Alright, so today we have a lesson on the mean value theorem. The mean value theorem says that if f is continuous on AB and differentiable on AB, then there is at least one CE of AB such that the inverse of f of C equals f of B minus f of A divided by B minus A. This also makes true that the slope of the secant line is the slope of the tangent line at least once. So for our first example here, I'm going to pretend that I can block that. For the function f of x equals x minus 1 to the 8th power, find all the possible values of c that satisfy the mean value theorem over the interval 0 to 2. So we can write it like this. This is the way we're going to write it in the end. And if f of x equals g of x to the n, then the inverse of f of x equals n to the g of x to the n minus 1 of g of x. It's just another way that we know we can write that. So plugging in our values here, we have f of 2 minus f of 0 over 2 minus 0, which is equal to 2 minus 1 to the 8th minus 0 minus 1 to the 8th over 2. And we get that by plugging in our function from above. And that equals 0. So the inverse is 8 times x minus 1 to the 7th times 1. And then we get 8 to the x minus 1 to the 7th. Just by putting that times 1 in there, doesn't change anything. So we can then plug in 0 because the inverse is there. So 0 equals 8 to the c minus 1 to the 7th because there's a c there. We were able to function that from before. 0 equals c minus 1 of s7. All that's doing is dividing the 8 out. 0 divided by 8 is just 0. Then we square root that 7 out, which 0 squared root by 7 is nothing. So c minus 1, and then we add 1, c equals 1. And that's how we get the answer of that one. And then for example 2, same thing. For the function of f of x equals the square root of x, we got to find all the possible values of c that satisfy the mean value theorem over the interval 4 and 9. So this is our function there. A equals 4 and b equals 9. That's how we get a and b. So if f of x is continuous on a to b, which is the mean value theorem, and differentiable on a to b, which is still the mean value theorem, then there exists c in a to b such that this. So what this is saying is that 4 has to be less than c, which is less than 9. So now we know that c is between 4 and 9. I get that math by, this is also the inverse here, so the d of x of the ax of the n equals a n x n minus 1. So the inverse of f is the derivative of the square root equals the derivative of x to the 1/2, because that's just factoring that out. And then we get 1/2 of x, 1/2 minus 1, and then we get 1/2 x to the negative 1/2. So then we go over here, we can plug in c to try to get these numbers here. This is what we're plugging in here. So 1/2 to the c to the negative 1/2 coming from here. We get f of 9 minus f of 4 over 9 minus 4, which is equal to the square root of 9 minus the square root of 4 over 9 minus 4, which, once we do all that math there, square root of 9 is 3, square root of 4 is 2, 9 minus 4 is 5, that's 1/5. So lastly, we can come over here. We know that this is equal to 1/5. So then we can divide, I guess, multiply that 1/2 over to get 2 over 5. And then get that negative out, flips that over. And then once we get that out, we get 5 over 2 to the squared, which is 25 over 4, which we get roughly 6.25 for c. All right, so overall, for the mean value theorem, don't forget that f is continuous on a to b and differential on a to b. Then there is at least one c of e of a of b, which makes f prime of c equal to f of b minus f of a divided by ba.